Hello. In this presentation, we are going to solve the fuzzy traveling salesman problem for 4 cities, C1 through C4. The method we use is backward dynamic programming, in which travel costs are represented by triangular fuzzy numbers instead of fixed values. The goal is to find a route that minimizes the total fuzzy travel cost. In this problem, we want to find the optimal order to visit 4 cities, starting from the origin city, visiting each city exactly once, and returning to the starting point, while keeping the total fuzzy travel cost as low as possible. The solution method is backward dynamic programming. In this approach, we start from the final stage and work our way backward, making the best decision at each stage. There are 3 key concepts. First, the stage, or N, which represents each stopover along the route. Second, the state, or I, which is the origin city at each stage. And third, the action, or K, which is the destination city chosen at each stage. In the real world, the travel cost between 2 cities is never a fixed number. There might be traffic, road conditions may vary, or fuel costs may differ. For this reason, each cost is represented by a triangular fuzzy number with 3 values. The first value is a 1, the lower bound, the minimum possible cost. The second is a 2, the modal value, the cost with the highest likelihood of occurring. The third is a 3, the upper bound, the maximum possible cost. To compare routes with each other, we use the BNP formula, which stands for Best Non-Fuzzy Performance. This formula converts a fuzzy number into a single crisp value, BNP equals a 1, plus the quantity a 2 minus a 1 plus a 3 minus a 1, all divided by 3. The table on this slide shows the cost matrix for travel between cities. For example, the cost of traveling from C1 to C2 is 1, 2, 3, meaning a minimum of 1, a most likely value of 2, and a maximum of 3. The cost from C1 to C3 is 8, 9, 10. From C2 to C4 it is 3, 4, 5. Cells marked with infinity mean a city cannot travel to itself. We assume that City 1 is the starting point, so after visiting all cities, we must return to City 1. At Stage 1, we have 3 possible cases, one for each non-origin city, where each city returns directly to C1. The cost is simply the direct return cost to C1. The formula for this stage states V tilde of I and the set 1 equals C tilde from I to 1. Let's go through the table row by row. Row 1, City 2. City 2 wants to return directly to C1. From the cost matrix, the travel cost from C2 to C1 is 0, 1, 2. Since there is only one option, F1 star equals 0, 1, 2, and K1 star equals 1. Row 2, City 3. City 3 returns directly to C1. Note that the cost from C3 to C1 is not 14, 15, 16. That is the cost in the other direction. Looking at the matrix carefully, the return cost from C3 to C1 is 3, 4, 5. So F1 star equals 3, 4, 5, and K1 star equals 1. Row 3, City 4. City 4 returns directly to C1. The cost from C4 to C1 is 5, 6, 7. So F1 star equals 5, 6, 7, and K1 star equals 1. At this stage, since there is only one choice available, K1 star is always equal to 1. At this stage, each city must visit one more city before returning to C1. The formula states V tilde of I and J equals C tilde from I to J plus V tilde of J and 1. In other words, the cost of going to city J plus the best cost we already calculated for city J in the previous stage. Row 1, City 2. City 2 can go to either City 3 or City 4. Option K equals 3. City 2 travels to C3. The cost from the matrix is 5, 6, 7. Then C3 returns to C1, which was calculated in the previous stage as 14, 15, 16. Adding them together, 5 plus 14, 6 plus 15, 7 plus 16 equals 19, 21, 23. The BNP equals 19 plus 21 minus 19 plus 23 minus 19 divided by 3, which gives 21. Option K equals 4, City 2 travels to C4. The cost is 345. Then C4 returns to C1, which was 567 from the previous stage. Sum 3 plus 5, 4 plus 6, 5 plus 7 equals 8, 10, 12. BNP equals 8 plus 10 minus 8 plus 12 minus 8 divided by 3, which gives 10. Since BNP equals 10 is less than BNP equals 21, F2 star equals 8, 10, 12, and K2 star equals 4. This means City 2 should go to City 4 first. Row 2, City 3. City 3 can go to either City 2 or City 4. Option K equals 2. City 3 travels to C2. The cost is 6, 7, 8. Then C2 returns to C1, which was 0, 1, 2 from stage 1. Sum 6 plus 0, 7 plus 1, 8 plus 2 equals 6, 8, 10. BNP equals 6 plus 8 minus 6 plus 10 minus 6 divided by 3, which gives 8. Option K equals 4. City 3 travels to C4. The cost is 7, 8, 9. C4 to C1 was 5, 6, 7. Sum 12, 14, 16. BNP equals 14. Since BNP equals 8 is lower, F2 star equals 6, 8, 10, and K2 star equals 2. Row 3, City 4. City 4 can go to either City 2 or City 3. Option K equals 2. City 4 travels to C2. The cost is 2, 3, 4. C2 to C1 was 0, 1, 2. Sum 2, 4, 6. BNP equals 4. Option K equals 3. City 4 travels to C3. The cost is 11, 12, 13. C3 to C1 was 14, 15, 16. Sum 25, 27, 29. BNP equals 27. Since BNP equals 4 is lower, F2 star equals 2, 4, 6, and K2 star equals 2. At this stage, each city must visit 2 more cities in sequence before returning to C1. We build on the results from the previous stage. Row 1, City 2. 2 possible routes, route 2 to 3 to 4 to 1. City 2 travels to C3. Cost 5, 6, 7. Then from C3 it must visit C4 and return to C1. This value was calculated in the previous stage for City 3 when K equals 4, which was 12, 14, 16. Sum 5 plus 12, 6 plus 14, 7 plus 16 equals 17, 20, 23. BNP equals 20. Route 2 to 4 to 3 to 1. City 2 travels to C4. Cost 3, 4, 5. Then V tilde of C4 with 3 taken from stage 2 for City 4 at K equals 3, which was 25, 27, 29. Sum 3 plus 25, 4 plus 27, 5 plus 29 equals 28, 31, 34. BNP equals 29. Since BNP equals 20 is lower, F3 star equals 17, 20, 23, K3 star equals 3, K2 star equals 4, and K1 star equals 1. Row 2, City 3. 2 possible routes. Route 3 to 2 to 4 to 1. City 3 travels to C2. Cost 6, 7, 8. V of C2 with 4 from the previous stage equals 8, 10, 12. Sum 14, 17, 20. BNP equals 17. Route 3 to 4 to 2 to 1. City 3 travels to C4. Cost 11, 12, 13. V of C4 with K2 from the previous stage equals 2, 4, 6. Sum 13, 16, 19. BNP equals 16. Since BNP equals 16 is lower, F3 star equals 13, 16, 19, and K3 star equals 4. Row 3, City 4. 2 possible routes. Route 4 to 2 to 3 to 1. City 4 travels to C2. Cost 2, 3, 4. V of C2 with 3 from the previous stage equals 19, 21, 23. Sum 21, 24, 27. BNP equals 24. Route 4 to 3 to 2 to 1. City 4 travels to C3. Cost 11, 12, 13. V of C3 with 2 from the previous stage equals 6, 8, 10. Sum 17, 20, 23. BNP equals 20. Since BNP equals 20 is lower, F3 star equals 17, 20, 23, and K3 star equals 3. This is the final stage. City 1 is the starting point and must decide which city to visit first. The rest of the route is then determined by the results from previous stages. Route via City 2, from C1 to C2. Cost 1, 2, 3. Then V of C2 with 3, 4, which was F3 star for city, 2 equals 17, 20, 23. Sum 1 plus 17, 2 plus 20, 3 plus 23 equals 18, 22, 26. BNP equals 18 plus 22 minus 18 plus 26 minus 18 divided by 3, which gives 22. Route via city, 3. From C1 to C3. Cost, 8, 9, 10. V of C3 with 2, 4, which was F3 star for city, 3 equals 13, 16, 19. Sum, 21, 25, 29. BNP equals 25. Route via City 4, from C1 to C4. Cost, 9, 10, 11. V of C4 with 2, 3, which was F3 star for City 4 equals 17, 20, 23. Sum, 26, 30, 34. BNP equals 30. The lowest BNP is 22, which belongs to the route via City 2, therefore K4 star equals 2. After completing all 4 stages of backward dynamic programming, the optimal route has been identified. C1 to C2 to C3 to C4 to C1. We can trace this path through the tables. At stage 4, K4 star was 2, so we go from C1 to C2. At stage 3 for City 2, K3 star was 3, so we go from C2 to C3. At stage 2 for City 3, K2 star was 4, so we go from C3 to C4, and at stage 1, all cities return to C1. The total fuzzy cost of this route is 18, 22, 26, with a BNP of 22, lower than any other possible route. This method allowed us to model real-world cost uncertainty using triangular fuzzy numbers, while still identifying the optimal path. Thank you for watching. We hope this video was helpful, and we would love to hear your thoughts in the comments.